So basically we have 5 models and we want to evaluate what the models predict when x equals 2. So we're just going to plug these into these equations. So I'm going to probably do them in different colors so you can see what's what. So we're going to do A first. So over here for A, I'm going to say the natural log of y hat is equal to 1.2 plus 0.8x, but we're being told that x is equal to 2. So this will be fun to do. So we gotta plug that into a calculator. So I'm going to say 1.2 plus 0.8 times 2. Now, order of operations will work the same, but probably as a good practice, you could put it in parentheses like this, because that's how I wrote it down. And I get 2.8. Oh, that's not that hard, Mr. Adams. Well, I need y hat is the problem. So what I have, technically, I have the natural log of y hat is equal to 2.8. But I need y hat. So this is a thing that I do to do it graphically, but I still need to know the y value to make the prediction. So how do I pull that y hat out of the natural log? Easy. I'm going to raise this to the e, and I'm going to raise this to the e. Because the exponential, raising something to the e, cancels. These are inverse operations. In other words, the natural log cancels with the e, and I get y hat. That was simple enough. But that's equal to e raised to the 2.8. So I guess I better plug that in the calculator. See what that is. So then I come to my calculator. Now the e is this little bad boy here, so I got to hit second and see how that says e. And then I'm just going to plug in 2.8. Well, bam, with the bacon sizzle, I get 16.44. So let's take a look-see at that. So this whole thing is equal to 16.44. Oh, that was pretty easy. So I got to do this with all of these. So let's do the next one. I've got the square root of this thing. So I'm going to do that over here. For B, I'm going to take the square root of y hat is equal to 1.2. The good news is that most of these, the values are going to be the same, right? So what's the value of this bad boy? Well, it's still 2.8, right? 2.8. But I've got the square root of y hat, but I want y hat by itself. So how do I undo a square root? Square it. Whatever I do on one side, I got to do to the other side. So when I square a square root, because they're inverses, I'm left with the base, which is y hat. And then I just got to take my 2.8 and square it. So I'm going to say 2.8 squared. Well, bam, with the bacon sizzle, 7.84. Now that's quite a difference from 16.44, don't you think? Let's keep moving, trucking along here. For C, we're going to do 1 over y hat. So let me put that here. 1 over y hat is equal to this 1.2, yeah, 2.8, but I'll write it out because I like to write things. But yeah, it is going to be the 2.8, right? So I've got 1 over y hat is equal to 2.8. So now there's a shortcut here. You can, if you cross multiply and divide, what we'll end up with is y hat is equal to 1 over 2.8. In other words, you just switch these two. That's a shortcut you could do. And then let's plug that in the calculator. 1 divided by 2.8. So I'm going to say 1 divided by 2.8. Whoa, that's a completely different answer. So this is going to be 0.36. Okay. But yes.
What are voluntary circles? What are
I don't know. I read that. I have some questions for clarity. So I don't know. You can ask if you want and then let me know.
Okay. Kind of cryptic there.
Yeah. That's staying in the video. So D is y hat, so we're already solved for y hat. That's good. But I think it's 1.2. Oh, yeah, this is great. So this is 1.2 plus the, is it 0.8 times the natural log? Yeah. 0.8 times the natural log of x. Oh, wait, but we know that x has got to be 2. So we'll get a little bit different number here. So let's plug that in the calculator. So I'm going to say 1.2 plus, and then the natural log, see this button right here? You might say, well, if it says natural log, why don't we list it as log? Like, why is it listed as ln? You got to remember, like, Americans don't invent this math, the Europeans do. So it's the European, Romantic languages tend to put the descriptor after the actual word that it's being described. So the way they pronounce it is the equivalent of log of natural. That's why it's ln. But anyways, I already screwed it up though with my fancy linguistic thing here. So it's plus, wasn't it 0.8? Yeah, times the natural log of 2. So now let's see what we got there. 1.75, does that seem right to you guys? Yeah. So let's do this. Now you might say to yourself, well, what is, all these numbers are different, but remember the model changes. You have the input value, but it'll fall within the group. In other words, when you plot this data, this predicted y hat value would be within the group. You're changing all the values. Your raw input is x equals 2, but you're manipulating the data in a way that it graphs easier, that you could see things that you wouldn't normally see. Specifically, we're straightening slightly bent data. So remember that for a linear correlation, you need straight data, right? And so we want to do linear correlation because everybody knows y equals mx plus b. The slope is the rate of change, y is the initial condition, and people understand that. So we manipulate the data to make it look like that. When you manipulate the data, these are the predicted values for y within that manipulated data set. Okay, so let's do the last one. E. We'll do that one in black. So now this one is a little different. It is the, we'll do it over here. I'm starting to run out of space. This is the one that needs the most space too. The natural log of y hat is equal to 1.2 plus 0.8 times the log of x, which in this case we're told is 2. Whoops. Put 2 2s. Got a little happy with my tablet thingy here. So now this is some cool stuff. This stuff on the left looks complicated, but really it's a numerical value. So let's find that first. Let's plug that in the calculator. So I'm going to say 1.2 plus 0.8. Now, when I just say log, do you know what that's called? This is called the common log. That means it's the base of 10, right? But when I plug this in, it's going to give me a numerical value of 1.44. Okay. All right. So what does that have to do with the base of 10? Well, let me show you. So then let me rewrite this. This is the log base 10 of y hat is equal to, what did I say, 1.44? Now, if I have a log base b of x, and that is equal to y, this is really my base, right, raised to the y should equal my x value. Now that's a little confusing, but basically what I'm saying is y hat is equal to my base, which is 10, raised to 1.44, whatever that thing is. So I'm just going to go into my calculator, and I'm going to say 10 raised to the, now here's a little trick. I want to take this number and put it in here. It was an answer, so I'm going to hit second and see where it says ANS here. Boom. And that just pulls this answer in here, and I get 27.59 roughly. Okay, any questions on that? No. So the trick here was just doing regular pre-calculus algebra, but you got to solve for y hat at the end. And if you're a little rusty with your logs, you would get stuck. Okay.